Here we are discuss with the introduction of database system. In this session, we learn to different types of database users, different types of views. Here, at the end of this session, the student will be able to give a brief database applications. The student can be able to create tables and able to perform queries. Along with that, they can be able to know about different types of users, different types of programmers, how we can create a query and how we can create tables like this. Now here in this session we start with the database applications and examples. Database applications are the application where the database will be get used. Now here we consider about the enterprise information, sales, customer, product, purchase. In case of accounting, in case of banking, there are different types of accountings will be there. In that case, we can also require a database system. Here we can consider the human resource information about employees, salaries, payroll. These are the different types of applications of database. Again, we can consider in case of manufacturing, banking and finance with respect to customer information, account, loans and banking transaction, credit cards, transactions, financials and purchase of financial institution and universities for a record of student for the purpose. Again, we can use the database. Here, in case of airlines, for reservations of airlines, similarly we can consider the train reservation, bus reservation, telecommunications, then web-based services like online retailer, order tracking, customer recommendation, online advertisement, documents database, navigation system for maintaining the location of various place of interests along with the exact routes of roads, train system. Here we can consider a database system. Now here we discuss about the purpose of database system. In the early days, a database applications were built directly on top of file system, which leads to data redundancy. That is nothing but duplications of data will be happen and inconsistency. Data is stored in multiple files format, resulting in duplications of information in different files. Difficulties due to which difficulties will be occur to accessing the data. For that purpose, we need to write a new program to carry out each new task. The data isolation, multiple files and formats, integrity problem, integrity constraint become buried in program code rather than being stated explicitly. Hard to add new constraint or change existing ones. Then atomicity of updates. Failures may leave database in an inconsistent state with partial updates carried out. For example, transfer of funds from one account to another account, concurrency access by multiple users, concurrency access needed for performance, uncontrolled concurrence access can lead to inconsistency. Here we can consider example, two people reading a balance say 100 and updating it by withdraw money C50 each at the same time. Security problem also there. Hard to it is hard to provide user access to some but not all data. Database system offer solution to all the above problems or whatever the problems we discuss. That's why we have to consider database system. Data models. Before going to data models, we can discuss about data. Data is nothing but a raw fact or raw material or information. Information that is nothing but a process data. In a layman way, we can consider a simple example of data and information. Suppose we can consider example of ice cream is a information or process data. But in case of that, we required cone, milk, ice. That is nothing but we can consider the raw fact or data. A collections of tools for describing data models, we require data, data relationship, data semantic, data constraint, a relational model, ER model, that is nothing but integrated relational data model, object-based data models, semi-structured data model, other alter models like network model, hierarchical model. Now here, we consider a simple example of relational model. Here, all the data is stored in various tables. Example of tabular data in the relational model. Here we consider a simple example of the instructor table. The blue line, there is ID, name, department name, salary. These are the columns and the each record will be provided with respect to that column is nothing but this row. and we can also refer it as a tuples. Here again, we can consider a sample relations of the instructor table and the department table. Next, view of data. Here is a simple view architecture for a database system. In that case, we can consider a different types of views. First one is a view level. Here it will be considered view 1, view 2, view n. It is depend on the end of user how they can view the data. Then a logical level. In case of logical level, we can consider what data can be actually stored. That is nothing but a logical level. In case of physical level, it consider how we can store a data in a database. That is nothing but a physical level. Then similar instance and schema, similar to types and variable in programming language. Logical schema, the overall logical structure of the database. For example, the database consists of information about a set of customer and accounts in a bank and the relationship between them. Analogous to type information of a variable in a program. Physical schema, the overall physical structure of database. In simple, we can consider the overall structure of database is nothing but a schema. Instant, the actual content of the database at a particular point in time, analogous to the value of a variable. Physical data independence, the ability to modify the physical schema without changing the logical schema. Applications depend on the logical schema. In general, the reference between the various levels and components should be well defined so that the changes in some parts do not seriously influence other. Data definition language. Now there are different languages like data definition language, data query language, data manipulation language, data control language. Here we discuss one by one. A data definition language. One more point with respect to data definition language. Whatever the commands we can consider with respect to data definition language, all these commands are by default commit. Means whenever we can perform these data definition language commands, after that they are by default command or we cannot be rollback. Here we start with the data definition language, a specification notation for defining the database schema. For example, we can create a table instructor with the columns ID, name, department name and salary. Here with respect to ID, character, that is nothing but a data type of that particular ID column, and we can consider size as a 5. Similarly for name, varchar 20, for department name, varchar 20, and salary we can consider numeric 8,2, that is 8 decimal point, and 2 is after 2 decimal, after the decimal we can consider 2 points. Then DDL compiler generator a set of tables, template store in a data dictionary. Data dictionary contains metadata. Metadata is nothing but data about data. Database schema, integrity constant, primary key, that is ID, uniquely identify instructor. Primary key is that is nothing but unique and cannot be null. Then authorization, who can access what. Then data manipulation language, languages for accessing and updating the data organizing by the appropriate data model. A DML, also known as a query language. Two classes of languages: pure, which is used for proving properties about computational and for optimizing power. For example, relational algebra, tuple relational calculus, domain relational calculus. These are the part of the pure. Then commercial, used in commercial system. SQL is most widely used commercial language. There are basically two types of data manipulation language: procedural DML, that required user to specify what data are needed and how to get those data. Then declarative DML require a user to specify what data are needed without specifying how to get those data. Declarative DMLs are usually easier to learn and use than are procedural DMLs. Declarative DMLs are also referred to as a non-procedural DMLs. The portion of a DML that involve information retrieval is called a query language. SQL query language is non-procedural. A query takes as inputs several tables. There is possible only one and always return a single table. Example, to find all instruction in computer science department, here we consider select name from instructor where department name is equal to computer science. SQL is not a Turing machine equivalent language. To be able to compute complex function, SQL is usually embedded in some higher level language. Applications program generally access database through one of language extension to allow embedded SQL application program interface which allow SQL query to be sent a database. Non-procedural query language such as SQL are not as powerful as a universal Turing machine. These are some access from application program. SQL does not support action such as input from user, output to display, or communication over the network. Such computations and actions must be written in a host language such as C, C++, Java, or Python with embedded SQL queries that access the data in the database. Application programmer are the programmer that are used to interact with the database in the fashion. Database design, the process of designing the general structure of database, logical design, deciding on database schema, database design require that we find a good collection of relation schema. Business decision, what attributes should we record in the database? Computer science decision, what relations schema should we have and how should the attributes be distributed among the various relation schema. Physical design, that deciding on the physical layout of the database. Database engine, a database system in a partition into models that deal with each of the responsibilities of the overall system. The function components of database system can be divided into the storage manager, the query procedure components, the transaction management component. Here we start with the storage manager, a program model that provide the interface between the low level data stored in the database and the application programmer and queries submitted to the system. The storage manager is responsible to the following tasks. There is interaction with the operating system file manager, effective storing, retrieving and updating of data. The storage manager components include authorization and integrity manager, transaction manager, file manager and buffer manager. Authorization and integrity manager are responsible for the authorities, that is nothing but who can access the data. Transaction manager, whatever the transaction we can consider for that purpose, the transaction manager is responsible. File manager, it is nothing but a related to file, and buffer manager, whatever the temporary storage we have to provide for that purpose, we consider the buffer manager. Then storage manager, the storage manager implements several data structure as a part of the physical system implementation. Data files store the database itself, data dictionary store metadata about the structure of the database, in a particular the schema of the database. Indices can provide fast access to data items. A database index provide pointers to those data items that hold a particular value. Query processor, the query processor component include, again it is a main part, a DDL interpreter which interprets the DDL statement and records the definition in the data dictionary. DML compiler translate DML statement in the query language into an equivalent plan consisting of low level instruction that the query evaluation engine understand. The DML compiler perform query optimization, that is pick the lowest cost evaluation plan from among the various alternatives. A query evaluation engine which execute low level instruction generated by the DML compiler. Here we can consider query processing, parsing and translation, optimization and evaluation. Query, then it will be get parsed and translated, then relational algebra expression we can optimize, then execute the plan. It can be get evaluated by evaluation engine and we get the output of that query. And the below part which can be shows the database. The transaction management, a transaction is a collection of operations that perform a single logical functions in a database application. Transactions management components ensure that the database remains in a consistent state despite system failure and transaction failure. Concurrency control manager control the interaction among the concurrent transaction to ensure that consistency of the database. Database architecture, there is centralized database, one to a few cores, shared memory, client server, one server, machine execute, work on behalf of a multiple client machine, parallel databases, many core share memory, shared disk, shared nothing, distributed database, geographical distribution, schema or database heterogeneity. Database applications are usually partitioned into two or three parts: two-tier architecture and three-tier architecture. In case of two-tier architecture, the application resides at the client machine where it invokes database system functionally at the server machine. Three-tier architecture, the client machine act as a front end and does not contain any direct database calls. The client and communication with an application server, usually through a forms interface. The application server in turn communicate with the database system to access data. Here we consider a sample visual of two-tier and three-tier architecture. That will be get clear your idea with respect to two-tier architecture and three-tier architecture. Database users, there are four different types of database system users. Naive users, it is also referred as unsophisticated user who interact with the system by invoking one of the application program that have been written previously. Application programmer are computer professional who writes the application program. Sophisticated user which interact with the system without writing a program, using a database query language or by using tools such as a data analysis software. They can be interact with the system. Specialized user write a specialized database applications that do not fit into the traditional data processing framework. For example, CAD, graphic data, audio, video. Database administrator, a person who has the central control over all the system is called a database administrator. In short, we can refer as a DBA, who functions are schema definition, storage structure and access method definition, schema and physical organization modification, granting of authority for data access, routine maintenance, periodically backup the database, ensuring that enough free disk space is available for normal operations and upgrading disk space as required, monitoring jobs running on the database and ensuring that performance is not degraded by very expensive tasks submitted by some users. Here we can see some history of database system. 1950 and early 1960, data processing using magnetic tapes for storage. Tapes provided only sequential access. Punch cards for input. Late 1960s and 1970s, hard disks allowed direct access to data. Network and hierarchical and models in widespread use. TED code defines the relational data model would with the ACM Turing Award for this work. IBM research begins system R prototype. UC Berkeley, that is Michael Stoneberger, begins Ingress prototype. Oracle release first commercial relational database, high performance for the era, transaction processing. In 1980s, research relations prototype evolve into commercial system. SQL becomes industrial standard. Parallel and distribution database system, Wisconsin, IBM, Teradata, object-oriented database system. In 1990s, large decision support and data mining applications are introduced. Large multi-terabytes data warehouses and emergence of web commerce. Then 2000, big data storage system is introduced. Google Big Table, Yahoo Peanuts and Amazon NoSQL system, big data analysis beyond SQL, MapReduce and Fresh. In 2010s, SQL Reloaded with respect to SQL front-end MapReduce system, massively parallel database system and multi-core main memory database. Thank you.